Good morning, everyone. So I'm excited to talk a little bit today about the workflow management tools that we've been developing in the data sciences team at Oregon. So I'll give a little high-level overview and talk about sort of the motivations and kind of highlights of using a tool like Balsam on Theta, and then I'll give a little bit more detailed code examples of how to use the module on Theta if any of you are actually interested in starting out on the machine. So kind of the motivation here for a tool like Balsam is that in the regime when you have a huge number of jobs to run, it can become very difficult to manage the parallel execution and sort of tracking state of your workflow. So the typical solution is to use something like an ensemble job script, like I show here. This is a solution that's widely used on Theta and very satisfactory if you have a small number of runs. But when you go to a very large number of jobs, the sort of human-in-the-loop effort becomes unmanageable. And this is caused by a number of issues. Specifically at the ALCFs, we have sort of restrictive queue policies that favor capability jobs. So, bundling small jobs into large jobs is really favored if you want to get a lot of small calculations through. And then even once you're through the job queue, the facilities for launching a large number of small or parallel programs are kind of lacking. So we're looking for tools that sort of go a little bit beyond the typical ensemble job scripts and additionally give us useful ways to track calculation errors and timeouts and sort of manage a workflow over possibly a life cycle of several weeks and numerous job submissions. So Balsam is attempting to solve this problem in a way that's very much centered around a database of tasks. With Balsam, you own your own sort of stateful task database, which has an entry for every application run that you want to perform in the future. And you let Balsam take over the process of packing, scheduling, and executing these tasks in parallel across the compute resources that have been allocated to you. Some of the highlights here are that Balsam is really emphasizing ease of use. And in that sense, I mean, there's absolutely no modification required to your applications. Balsam runs them in a very loosely coupled way, which also confers a strong task level fault tolerance, and jobs will not go down even if you have some fatal errors in one or two tasks in your workflow. There's a Python API for job control, which supports more advanced dynamic workflows like you would see in a package like Fireworks. And the provenance data that's recorded back to the database sort of gives you a lot of useful statistics of throughput and job utilization over time, sort of for free. And this is a well-tested code on Theta. So in the last year, we've worked out a lot of kinks in Balsam and scaled to fairly large node counts. So this graph shows for an ADSP project where we were running a large number of density functional theory calculations. We sort of had well over 1 million calculations to run. The database was able to accommodate the full set of tasks. And then the figure shows sort of the kind of throughput analysis that you can get for free with Balsam. So the black curve, which is plotted against the left axis, shows the number of completed jobs over time, and this is for about half of the database. And then the blue curve shows the number of nodes actively consuming jobs at any given time. And so you can see that we have up to 5 jobs at a time, each job using 802 nodes. And all of these jobs are cooperatively pulling tasks from the database and completing them. And so this is sort of a nice way to get a lot of work done spread over multiple batch jobs. in a way that doesn't require any manual packaging or redispatching of tasks. And this is in production, as I said, on Theta. We have a Balsam module available with this command module load Balsam, and I'll go through some of the details of using this and getting started with the command line on Theta. So first, I just want to provide a little bit of a high-level overview of exactly what are the Balsam components, where are they running in the context of a machine like Theta. Balsam is designed to be largely portable. It can run on your laptop or a GPU cluster like Cooley. But in the context of Theta, typically you'll have this component, the Balsam database, which runs on a login node. And this is a server. The backend we go with is the Postgres SQL database. And essentially the key component here is a Balsam job table, which is holding one row for every task in your database. And we interface to this with Django, so there's basically even developers don't really need to know much in the way of SQL to manage this. There's a very nice Python API to control your database of tasks. And this also supports very high concurrency in terms of several jobs concurrently pulling tasks from the database. The launcher component is a sort of a dynamic pilot application that will actually run inside of your job allocation. So once you submit a job to run and it starts up on in this case, the mom nodes of Theta, we call this component the launcher. It connects back to the database, dynamically pulls tasks, and as it executes them, it updates the database with metadata about the status of your job. And you can submit launcher jobs directly on, and then there's this optional component, which we call the Balsam service, that can actually look at your job database and package tasks according to some pre-configured queue policy. And the service will actually interface with the system scheduler in Cobalt in the case of Theta and submit jobs on your behalf. And in this way, sort of completely automate the cycle of scheduling and parallel execution. So since this is very much centric on the database-centric tool, so I'm going to just talk about some of the fields that you can use to control the tasks running in Balsam. So there are a number of fields, or you could think of as columns in this database. We have things like job name, a tag for your workflow, description, which is optional, an override for the working directory if you want to specify your own directories where jobs run, as opposed to letting Balsam create directories on its own. And there's an arbitrary JSON data store, which is a sort of binary data store that you can leverage in the Postgres backend. We also have a number of fields to manage dependencies between jobs. So in the case that you have some dependency graph, you can specify arbitrary, as relationships between jobs, which can involve data movement from parent to child jobs, and as well as data staging. So with their facilities for moving data into Theta from remote locations and staging data out at the end of other jobs. We have a number of fields that actually control the execution. So you choose for each task an executable or application, and the execution can be controlled through environment variables and command line arguments to your application, as well as pre and post processing scripts that run in an environment aware or a job aware environment. So one of the advantages, as I said, of using the Python and the Django object relational abstraction of the database is that you get very nice, clean statements like this. So users can get a direct handle on the database with this Balsam job API and do things, execute queries like this. So in this example, we're filtering for all jobs that have less than 128 nodes, contain the substring sim, and are finished. And we want to rerun these jobs. So that just takes a simple statement of update to a restart state. And then we have, for the actual management and creation of the database, a very simple command line interface. So all the details of SQL database creation, setup, and population of the Balsam job tables are encapsulated in this Balsam init commands, where you give a path to your Balsam directory for your project. And then in the case that you may have several Balsam databases, we make context switching very easy with a Balsam activate command, which is sort of borrows from the virtual env kind of idea to set environments. And then finally, when you run with the launcher, a lot of timing data at the sort of ensemble job level is collected for you. So the applications run unmodified without any instrumentation, but we collect a lot of data. So in this example, from a hyperparameter optimization run on Cooley, actually, this is an example of what the execution profile that you get from a run. So we see a blue curve staying nearly constant at 0 and showing newly created jobs. The orange curve shows tasks that are actively running at any given time under Balsam. And so this is sort of a proxy to check the utilization of your workers, and you can verify that your utilization is staying close to 100% in any given ensemble run. And again, the green curve shows throughput, which is something that you may also be interested in tracking at the level of a single job or across many jobs over time, as we saw in the introductory slides. And I also mentioned that tasks running under the launcher are also very fault tolerant. So the launcher is basically running each task in an isolated process, meaning when errors occur, it's able to capture that state, record tracebacks of the error, and then with commands like the Balsam ls, it's very easy to filter for failed jobs and get a history of timestamps of when errors happened and even the tail of the standard error and standard output to sort of see what went wrong.
Misha, I have a quick question. So
yeah.
When you talked about the launcher and the load balance, is this something that can happen while you're using Balsam to launch, or this is something you can do it only after it's done?
Yeah, so as the launcher, I'm not sure if I fully understood the question, but as the launcher is running, it's going to sort of on the fly pull as many tasks from the database as it can to keep your nodes busy, whether those are single node jobs or MPI jobs. And in that sense, it's sort of a first order load balanced execution scheme. So this is as opposed to like an ensemble job script where you sort of have a static definition of, I want to run these 10 applications in this script, and that's it. So
okay.
if things finish early or if things fail, Balsam will keep pulling new jobs to keep your nodes busy for the duration of time that you have them.
Okay, thank you.
Yep. Okay, so now I'll go on to a short tutorial on Theta. So Balsam does require Python 3.6, but I should emphasize that's really only for you need Python 3.6 running to control Balsam, manage your database, but in turn, Balsam can run any other application, including Python 2 or a version earlier than 3.6, like 3.5. So this is not a very severe restriction. If you, for some reason, want to stay with an earlier version of Python in your applications, this doesn't preclude that. But on Theta, to get started with Balsam, you would load something like the Cray Python module, which I have shown at the top here. And then, given that the Balsam module is loaded, you can run this Balsam command and see sort of a help menu for all the subcommands at the command line interface. And these instructions are sort of in lieu of an interactive demonstration, but you can follow these. This is sort of exactly cut and paste from a live terminal session. So the Balsam init is used to create a new database, and if that runs successfully, you should see a help message showing you how to get started. And then this Balsam activate command will actually start up the Postgres server if it's not already running, and set up your environment properly so that the rest of your session is talking to the right database. Now the key to getting started is to register an application that you want to run. So this first command, Balsam app, is the way to do that. You'll see here that we just provide a name or an alias for our code. In this case, I'm just using the bash built-in echo rather than a real simulation code. But this executable can be really any command line, whether it's a standalone binary or a binary joined with some arguments. And so once an application is added to the database, you should see this confirmation screen showing the values of fields. We've left description and pre-processing, post-processing steps blank. And then we can define a job to use this application. So you'll see with the Balsam job command, we create a task with a name and a particular workflow, which is a way of organizing related runs. And the key here is that we then specify the app that this job is running, and that's the say hello job that we just ran. And then we're going to append this argument of world, ! And on running this command, you'll see sort of a large confirmation screen showing you all the default values of parameters that were left out. So as you can see there, probably the most important things here are parameters like the number of nodes running, the ranks per node, and environment variables. And there are a number of options that you can use to fine-tune how your application is going to run inside of Balsam. And then at the bottom here, we see a working directory that's going to be auto-generated by Balsam, and basically the executed command is going to be just echo hello world. So we can populate the database with a number of jobs like this from the command line, and then use this Balsam ls command to list tasks in the database. You should see a screen like this, listing one row for each task that you've created. Each task is assigned a unique ID so that there's no issues with naming collisions. And then when you're ready to run, you use this command Balsam submit launch, which is a proxy for the qsub command line interface to the scheduler on the system. So with Balsam submit launch, the parameters look very much like qsub. You can give a number of nodes with the end parameter, the wall time in minutes with -t, and so on. The only difference here is that we specify a job mode here as either serial or MPI. So the serial job mode allows you to pack a large number of tasks that are not using MPI. They're running in one node, maybe with OpenMP or no parallelization at all. And in this case, Balsam can actually pack multiple tasks per node, and it can do all of this under one sort of MPI launch command. And in the other case, we have an MPI job mode, which supports launching basically, one app run per job, and your tasks can have use any number of nodes in that mode. So eventually, as this runs, the launcher will come online and pull tasks and run them, and you can track the status of your workflow with Balsam ls and see that eventually, in the successful case, jobs are marked as finished. All output goes into the Balsam database directory that you created. So in this case, inside of the testdb folder, you'll see a data subdirectory, and that houses. Yep.
We have a question.
Sure.
Eric asks, can you run more than one MPI job per node on Theta with Balsam?
No, that's not supported right now. So if jobs are using MPI, sort of one job is going to tie up a certain number of nodes, and then you can't have two jobs sharing a node.
Okay.
And that's really a limitation of the Cray application placement system. So this is something that we're sort of working on and looking for workarounds.
So something, Eric said thank you. So does Balsam is dependent on the version of the Python that you have on your environment, on your path?
Yes, but only for it only depends on the version of Python that was used to set up your database and manage it. So you can have applications running under Balsam that are using any version of Python you want. And that the submission script will tweak the environment so that it's always pulling the right version of Python to run the launcher for you.
So basically, as long as they match, it doesn't matter which version you're using, right? Your application and the Balsam environment, I guess.
Well, no, they don't even have to. Between your applications, don't even have to match. They can use any version of Python that you want, because they're completely separate processes. From the point of view of Balsam, your application is just some executable binary. It could be it could be anything. So if it happens to be a Python 2 interpreter, Balsam is agnostic to that.
Okay, thank you.
Sure. And then in the event that jobs fail, the Balsam LS will show a failed state like this. And then we can use additional flags to LS to get more information. So, for instance, we can use the -- state to filter for failed jobs only. And with the history flag, we can get sort of the metadata that was recorded for the job. So we get timestamps of each state as Balsam advanced the job through processing. And then in this example, we can see that after running for a few seconds, we recorded an error here, and then we get a piece of the traceback from the application. So this is sort of a convenient way to quickly spot errors and debug your workflow on the fly. And then say we fix the error in our application and we want to try it again. We can use commands like Balsam modify to select a substring of the job ID and say we want to modify the state to restart ready. And in that case, the next launcher job will pull the task and run it. And then you can also...
We have another question, sorry.
Sure.
So Mehta asked, all test outputs, including large data output, goes into the database. Basically the question is if the outputs are all going to like a one database.
So the outputs are actually going to the file system. You create a Balsam database, which is in a subdirectory of that overall database. So here, let me go back a couple of slides. So what you create is this test DB, and the first subdirectory that you see here, Balsam DB, is sort of an opaque Postgres database, which holds the metadata about your workflow. But all of the outputs from your applications are actually just ordinary file outputs going into the second data subdirectory. So you can opt to store JSON data, sort of arbitrary JSON data in the Postgres database, which can be very convenient for querying later. But by default, Balsam tries to stay out of the way as much as possible. And so in that sense, it runs applications as if you were running them from an ordinary job script, and the input and output looks very much like standard input-output to the file system.
In the continue of that question, you would want to output to be written to the Perl file system instead of the home directory.
Yes. Yeah. So in that case, you would just set up your that's probably the best practice, is to set up your Balsam database in a project's directory that belongs to you. and that way you're using the Lustre file system.
Okay, thank you.
Sure. So yeah, going back to modifying fields in the database, you can do this from the command line, and then you can also open up a Python interpreter and do sort of more flexible queries and updates like I showed in the introduction. So using this Balsam job objects filter, we can select a number of nodes, or I'm sorry, a number of jobs matching some criteria, and then update them, and then we get back here a confirmation of the number of tasks that were updated. In this example is 10. So that's all good for maybe inserting a few jobs and tinkering from the command line, but the whole point of Balsam is to manage a huge job campaign where you may have a lot of tasks to get done over some period of time. And in that case, that sort of leaves you with scripting, which is not really what we want to do. So we have a Python API as well, which is sort of hinted at in that last slide with modifying jobs. But we can also use the Python API to create a large number of jobs. And this is sort of, in our experience, the best way to get all the work into the database up front. So this is really up to you. It's very flexible in terms of how you want to structure your database populating code. But the key API here is that Balsam job constructor. So in this case, rather than using the Balsam job objects filter API, we're just using Balsam job as a constructor here. And each keyword argument is nothing but one of the columns in the database that you see with the ls command. So we can create a job with arbitrary name using a particular application. This example is from a chemistry workflow where we're running the FHI AIMS simulation code. We're running on one node and just 64 ranks per node. The one is understood in a default argument. And then we're using the CC depth flag here with CPU affinity and turning off OpenMP threading by setting this environment variable explicitly. So that's kind of the way that you can set jobs up. And this prep job helper function lives inside a loop where you can see here we're walking over a bunch of folders in some directory. So say you have a large folder of input files that you need to run for your simulation. You can use all the existing tools in the Python standard library, which are great for stepping through the file system and filtering jobs for whatever criteria you may have. And then we create a job for each one. And in this case, we're not explicitly saving the jobs in the loop, but in this final command here, we're inserting all of the jobs at once. So once you've done that, again, the submit launch command, which I showed, is the fastest way to just start running. You can submit several launcher jobs simultaneously. You can fill up the queue with launcher jobs if you want, and they will run as much work as they can on the nodes that they have and then quit. This is really largely an automatic process. If you want a little bit more control here, you can look at this job template file. So this is created automatically in your home directory. Once you start using Balsam, it creates a .balsam folder in your home directory. And the settings.json points at a job template file that looks a little bit like this. So this is an example of the job template, leaving out some stuff in the middle. But basically, you'll see that the command that actually runs on the head node is this Balsam launcher command, taking a specific job mode, sort of aware of the time limit in your job, and that's about it. So if you need to set any environment variables sort of globally for your job or load some modules, this is a good place to make that modification, and that'll sort of be a global effect on all of your jobs. And there's also a queue policy. If you're using the Balsam service, you can configure basically a number of jobs that can be queued in any given queue name, and then sort of set the step function of ranges of nodes and minimum and maximum wall times in each node range, and allow Balsam to submit jobs on your behalf. So finally, once you have a lot of work running, this Balsam LS with the by states flag is very helpful to get a global picture of your workflow. So this is something that we'd see in a typical workflow. So we can look at sort of at a glance how many jobs are finished, how many are running actively, and this is a good way to sort of verify nodes that are being used on the fly. And with that, I'll just turn to the last section here, which is just a few examples and highlights of more advanced workflows that you can set up with Balsam. And if you want more information on any of these, I'm happy to give more detailed examples. So please do ask any questions or shoot me an email if you want more information than is available here. In the case of dynamic workflows, we can create a DAG or directed acyclic graph of task dependencies with this balsam.launcher.dag module. So you can see in this example, we're sort of creating a fan out and then reduce pattern workflow of 5 jobs. And the way this happens is really simple. At the bottom of this code snippet, we have a loop over the middle tasks. And for each middle task, we're adding a dependency, the parent job to that task, and then finally from that task to...
Come on now, I was enjoying that.
To the bottom. Yeah, so that's a way to sort of define dependencies at a glance, and sort of without giving any concrete example of the work you're running. And then the rest of the stuff in that module is we can go into details offline, but the essence of this launcher.dag module is that it has a current job attribute. So when it's imported in the context of an application or the post-processing script of a particular application, it's aware of the job that's being processed. And so in that post-processing script, for example, you can query the state of the current job, check if there's an error, and look at the error code, and then maybe write some error handling logic into your workflow there to maybe parse your output file, reorganize your inputs, and then mark the state to try again. So this is where you can really inject custom error handling code or dynamic workflow graph modification logic. And so, yeah, you do this by attaching these kinds of scripts to your application. And then the other sort of neat dynamic feature that we have is the kill. So you can actually kill jobs as they're running. And the launcher will sort of react to this in near real time, stop a task that you've killed and replace it with new work. So in this way, you can actually modify the database, define new jobs while you have a batch job running, and the launcher will respond to this in real time. And then finally, for more dynamic workflows, and there are a lot of cases where you may have some kind of master worker pattern where one master app is itself connected to the Balsam database and spawning off tasks that you want to execute sort of through the database asynchronously and in a manner that's sort of managed by Balsam. And this is fairly easy to do with the API I already showed you, but users always end up writing their own logic to sort of pull the database, check if jobs are done. So we've introduced this async module that is sort of inspired by the concurrent futures API that already exists in the Python standard library. And so what we do is we can basically, in this code example, we are defining some callback function for a job. So say, in this case, when a job is done, this callback reads a file in the working directory of the job and basically returns the output as a string. And we can create basically a future on each Balsam job programmatically and register this future to execute some callback. And then we can wait on futures and pull them in ways that are sort of up to you in blocking ways or non-blocking ways. And this can be sort of a useful way to set up a more dynamic master worker kind of code. And with that, I'll say thank you to my team and the data science and all the sort of early users of Balsam and the ADSP projects. We have source code on GitHub. It's being publicly mirrored. Documentation is still sort of undergoing some revisions from older versions of Balsam, but I'm happy to answer any questions directly if you shoot me an email. And again, I would suggest if you're running on Theta to just use the module that's already installed there. And with that, let me know if you have any questions.
Thank you, Misha. That was very good talk. So please ask us questions. We have about 15 minutes.
Hi there. Thanks for the presentation. Does the Balsam work on Titan?
We haven't run it over there yet. Although, so when I talked about the architecture of Balsam, there are really only two places where it interfaces with the system, and that's in the launcher uses an MPI launch template, which is swappable, and the service uses a scheduler template. So it should be very easy to port to other systems, and it's already portable between very different clusters over here. So I would be optimistic, but I don't have an account over at Bridge, so I haven't tried.
Okay, thank you.
May I ask about the definition for creating the dependencies? I noticed you did that through like a Python script. Is that required? Can you create?
There's a command line for it too.
Okay, there is. Okay.
Yes, so there's a Balsam dep command where you give the parent ID or a substring of that long ID and the child ID, and it will create the dependency that way.
Okay. Okay.
Is there a way to interface with the scheduler to do slightly more complex things, such as pinning processes to cores for every job? Can you do something like that through Balsam?
So we don't do this through the schedule on Theta, at least. We have the Cray application launch command, and so that's sort of part of the MPI launch interface. We can specify CPU affinity through the flags to AP run, and so we can pin threads to cores that way, or you can set environment variables if you're using like Intel Xeon Phi CPU affinity options. I suppose if that's controlled by the scheduler, we could look at ways of doing that in the future.
Okay, thank you.
Yeah.
Let me
Go ahead.
a question about just logistics as far as the defined workflows in the Balsam database.
Yeah.
So if I'm logged into a login node and I want to let's say it's the next day, right? Now I come back, I have more jobs I want to run.
Yeah.
Will that database still exist, or do I have to recreate it every time I log in?
Oh yeah, it's persistent. So when you create it, basically everything is backed against the file system that it lives on. So
It is, okay.
you would create this database in your projects directory, and when you call Balsam activate, under the hood you're actually starting a server that all your clients will connect back to. But the server is syncing everything back to disk.
Okay, thank you.
Yeah.
Is that server persistent when you actually run? So say I were to submit a job like Balsam, say I were to activate the launcher, would that server persist past my session?
Yes. So if you look back at the job template, which is created for you automatically, there's this source Balsam activate line, Balsam launcher, and deactivate. Now, what activate will do is it checks a file that lives alongside your database with the host information. So if the server's already running, it will just connect to an existing one. If the server has gone down recently, it will just start a new one up for you. And then with source Balsam deactivate, the last process to check out will shut the server down if there's no one else talking to it.
Okay, so we have another question.
Yeah.
And Trevor asked, can you give an example of how you would use a Python script, look through a set of folders containing VASP input and launch jobs?
Sure. So that's sort of this is an example snippet here. It's really sort of depends on your directory structure.
Julian, can you please mute yourself?
Okay.
Yes. Okay. Thank you.
So here's an example where this is a little bit more involved, but this OS walk function, which is really it's just part of the Python standard library, is a really nice way to recursively walk through the subdirectories and files in some top level folder. So I like to use this, and then what you get through here is an iterator over tuples, which give you the top level path, and then all the subdirectory names and all the file names within that top level path. So in doing this, we can at each sort of iteration of this loop, we can check for file names matching some criteria, which is what I do in this first line here. And then if any files do match the criteria you're looking for, then you can slice up the paths, get the name that you want, and this block here in the inner loop is really up to you. It's how you want to organize your workflow, but ultimately all you do is you create one Balsam job instance here. So I'm using a helper function here. You don't have to do that, but you create a Balsam job. In this case, I'm using the staging URL to copy in a remote file. So this works for other kinds of transfers, but in this case, it's just going to do an ordinary copy. So it's going to copy in some XYZ file to the working directory of that job. So I collect all of these job objects, and rather than committing them to the database one at a time here, with this save API, I use this bulk create, and all that does is reduce I/O and save the insertion for the end of the loop. But that's kind of the general pattern for walking through some folders and creating jobs, which seems to be the overwhelmingly common pattern here.
Do you also have Pythons in your Balsam? Do you also have functions in your Balsam's Python interface to do things like number of processes per node and such fine tuning?
Yes. So if I go back to the fields, you have all these fields to control. In the sort of abstraction we're working with now, we have the number of nodes, ranks per node, and then here we can set CPU affinity options, which right now are being passed to the MPI launch template. And there we can do things like set the hyperthreads per rank and hyperthreads per core.
Cool, thanks.
Sure.
What's the difference between input files and stage in URL?
So this is something, yeah, we're in a later version, we'll probably organize this to be a little bit more clear. Input files defaults to the everything wildcard, and this only applies for dependencies. So this is what will be transferred from a parent job to a child job if you have.
I was just going to ask that question. So
yeah.
if you do have dependencies, right? So I have, job A takes an input file, produces an output file of some file name. I want to then immediately pass that to B, right, which does the same thing, input
yes.
to output. So I think this is the perfect time to do it. So yeah, do you want to talk a little bit more about how you link those files to the dependencies?
So Balsam is doing, it's just going to do symlinks in this case. So I kind of glossed over the notion of states here, but you sort of got an idea here that jobs are created, running, done, failed, and so on. Before any job runs, it goes through a stage in transition and a pre-processing transition, both of which are sort of optional, and they're in the simple cases they're just no ops. But if you have dependencies in your workflow, before any job runs, in the stage in transition, Balsam is going to look at that job, identify all of its parents, and then find any files matching any wildcards. So it's just input files is just a white space separated list of file wildcards, and it's going to symlink those into the child working directory. And we're working on a cleaner way of doing this in the future, where you can specify what moves for each dependency in your DAG. But right now, with what's on Theta now, this is the way to do it. And stage in URL can be a path on your file system, and this hasn't been tested recently, but there are a lot of transfer protocols supported, like for grid FTP and Globus transfers for stage in and stage out.
So one application we have is a reducing, it's just a single threaded, it takes multiple files of just, binary data and just combines them into one file. It does a little bit of sorting, but
yeah.
So in other words, many input files, and then you're ended up with one output file that basically has a suffix appended to it that says merged, right? So you could have like job 1, 2, 3, 4, and then you could have 1,000 of those, and then at the end it says job 1, 2, 3, 4 merged, essentially.
Okay.
Is it possible just to run through using that as a sort of a template? Is it possible to run through just a quick example of where you would put like the merged part? Like here's how I pass that merged file from A to B.
Passing the merged. So
job A, right, takes many files, combines them into a merged file, and then job B uses that merged file as an input, and then does your analysis.
Sure. If job A has a large number of input files, is A then have a lot of parent tasks? One for each input file, or
in this case, it's A is the top. So it was just many detectors detected events, and we just want to put them together. So in the example I'm thinking of, A is the top. So no, it's just all A does is look at a bunch of files and merge them and apply a little bit of logic.
Okay, so in that case, A has a large number of stage-in URLs. So in this case, you would just copy in all the files. The other very useful field here, if all these are just already sitting in a folder, make it easy for yourself and use this. Let's see, there's a flag called user workdir here, which is blank in this example, but it's fourth from the bottom. And you just point that at the existing directory that has the files you need. And instead of creating a directory, Balsam will run that task there. So A runs here, recognizes the files, creates the merged file, and then B is a child task of A, and in this input files, you could replace star with star.merged, and
Okay.
and that way only the merged file gets passed on.
Yeah, exactly. Okay. Okay, I think that makes sense. Thank you.
Sure. There's sort of a lot of with the variety of options, there are sort of a lot of equivalent ways of getting things done. So yeah, it just takes a little bit of playing around to decide the best way to do things.
On machines that have NVRAM, either local or shared, is there a way you can use that? I mean, we have an application where some of the files need to go to an NVRAM and some of the files need to go to the parallel file system. So is there a way you can do that?
So is this NDRAM only accessible from certain compute nodes then? Is that the idea, that not everyone can see the same memory?
Well, it depends. Summit has node local NVRAM, whereas Cori has NVRAM that is shared across compute
Okay.
nodes.
So if it's the problem, I think, arises when you have successive when you have a workflow with a chain of dependencies, and some child task is relying on local data from a parent. This is actually something a lot of people are interested in here in the context of the node local SSDs, but the idea may be the same for other levels of memory hierarchy. And we're looking at ways of handling this, but right now, I would say the best approach is just to bundle those dependent jobs in some wrapping script, so that you guarantee that they run sequentially on with access to the same files paths or locations. So it's very much up to the user to control, which whether you're using SSD for scratch or looking at some burst buffers. There's not a lot in Balsam that tries to step in there.
Okay, so but apart from any dependency issues, if you just have a single job that needs to write some of its files to an SSD and some of its files to the parallel file system, can you do that?
So we don't really provide any features there. No. Right now that each job is presumed to run in a set working directory, and if you're leaving all the defaults up to Balsam, they're all going to go in the file system that you created your database in. That being said, if you have control over your application, you can redirect output to specific locations there. But that's got to be handled at the application level rather than the Balsam level for now.
Okay, all right, thanks.